Hello and welcome back. Today we'll be using ladder logic programming to regulate the level in this water tank, but we're also going to incorporate an alarm system that will notify us in the case of a fault with our system. And this alarm system is going to be smart, and you'll see why if you watch the video. So stay tuned, smash the like button, and subscribe to the channel. So before we can get into programming a smart alarm system, we'll first have to make a quick program that will make us be able to drain and fill this tank. So we can see right now that the tank is full, so we'll quickly just make a program so that we can drain this tank. So we're going to need a contact in our logic that represents our drain button, labeled as drain command. So basically, when we press this button here, this contact in the logic will close. And so we'll use this signal in our logic to energize our drain solenoid, which will be represented by this coil in our logic, so that when we click this button, the drain solenoid will activate and the tank will empty. So before we give this a test, we'll just quickly make the same logic, but to fill the bucket back up. So we'll use our fill command. That's this other button. And that signal in our logic will be used to turn on our fill solenoid. So we'll go into run mode here and give this a quick test. You'll see if I press down the drain command, we get this signal here and we energize our output and the tank empties. And if we press the fill command, the fill solenoid will activate and the tank will fill up. So this is great and all, but because these are momentary push buttons, we actually want to make it so that it latches even after you release the button. You don't want to have to hold the button the whole time in order to drain and fill this tank. And this is actually quite easy to do. All we have to do is add a holding contact that will go in parallel with each of our inputs. So I'll move our fill command into this parallel branch and delete the old one. And we'll put this in parallel with a normally open contact that will close once we energize our fill output. This way, when we release our fill command, the fill output will stay on because of this contact that closed when we turn the output on. So now we'll see when we go run, we'll click and release the fill button, and we'll see that our fill is energized anyways, and that's because of this holding contact. Now all we need is a way to be able to break this circuit, because the fill command is on right now and won't turn off. See, we can drain the tank, but as soon as we release the drain command, the tank will just keep filling indefinitely. And that's because this holding contact, there's no way to turn it off. So we can use the signal from our normally closed stop button to feed a contact in our logic. And this way, because the stop button is normally closed and its input is normally energized, this contact in our logic will be closed under normal circumstances. If we click stop and break this circuit here, this contact will become de-energized and open up. So this way, when we go to run our program, we'll see we can click the stop button, and that will kill power to our fill output, which will in turn open up our fill contact here, and we have therefore unlatched the filling process. So when we release the stop button, we are good to drain the tank, and when we stop draining the tank, it won't automatically fill again. We're also going to want to add an automatic stop feature, so we can take a signal from this normally open high level limit switch, so that when the water fills up, this switch will close, energizing this input, and we can use this to break a contact here in our circuit. So we'll use a normally closed contact that will open up when we hit our high level limit switch. And so let's just watch this in action. I'll click and release the fill command button, and we'll see it fills. And when it hits the top, this switch closes, and that energizes this, opening it up, and we unlatch the holding contact. So I've copied the same logic from the fill command to the drain command here, with only one exception, that to turn off the draining process, we're using this normally open contact in our logic for the low level limit switch, instead of a normally closed one, as we did for the high level limit switch. This is because this low level float switch will basically always be closed. It will only open up once the level gets low, meaning this contact will normally be energized. So it will normally be closed, and it will only break the circuit and stop once the level gets low. So we'll just verify this. We can see that our low level limit switch is closed right now, energizing this input and closing this contact. So we should be able to drain the tank. But when the level gets low and the switch opens up, this input becomes de-energized and this contact opens up, breaking the circuit and unlatching the draining process. So now that we have a proper functioning system to actually control the filling and draining of this bucket, we can actually get to the main point of this video and design the smart alarm. So first we'll have to make some set conditions for the alarm, and we're going to say that if the level is past the high level limit switch, and if for whatever reason the tank continues to fill, we're going to say that after 5 seconds we'll turn on an alarm. So we'll go back into programming mode and make a new line here, and we'll make 2 series contacts. One of them will be closed if we have a high level, and one of them will be closed if our tank is filling. So only if both of these conditions are met, and if 5 seconds have passed. So we'll make an on delay timer and preset it to 5,000, because again, these timers are based in milliseconds. Then we want our alarm condition to be met. So I've created this fault here that we can trigger using this button that bypasses our high level limit switch in the logic, so that this way we can simulate a fault, because the logic we had before, we can't have the tank continue to fill after it's full. But this just simulates some real world fault that could be anything. So now what I'm going to do is go to run mode. I'm going to click our fault button, and so you'll see that we have a bypass here, and when we go to fill the tank, we'll see that this timer will start counting, and it should go up to 5,000 and then stop. So we'll go fill the tank, and you see it continues to fill even though our high level limit switch is closed, and then 5 seconds later our timer is finished counting. So we can use these conditions to set our alarm. So what we can do here is make a new line in our logic, and we will make the timer done bit. So after 5 seconds, this done bit will turn into a 1. It will close, and we can have this set our alarm. And we're just going to do a holding contact for the alarm so that the alarm will latch on in this scenario. So to turn off this alarm, we have a normally open clear alarm button. So in our logic, we're going to place a contact in series with this holding contact we made called clear alarm. And because this button is normally open, it will be a de-energized input, and therefore this contact will normally be closed. So we'll go into run mode here to simulate this and see why we placed our clear alarm contact where we did in the logic. So here we have the alarm condition met, and if we click the clear alarm button, the alarm doesn't actually turn off. That's because in parallel we have the fault condition bit that will always keep the alarm on if there's a fault. So this way, the only way to de-energize the alarm is to actually have the fault become cleared and then click the clear alarm button. So we'll just do a quick simulation of the entire process. We'll do a quick drain, and then when we fill it up, we'll actually introduce the fault, and then this way it will continue to fill even after it passes this high level limit switch, which will in turn trigger this timer, and then after the timer's done, the alarm comes on. And we're not able to clear the alarm until the fault goes away, and then we can hit the clear button. Yeah, and that's basically all there is to it. We've created a smart alarm system for our automated filling tank. So I hope you liked the process and learned something and had fun. We can make a more advanced alarm circuit in a future video. I think that'd be fun. So I'll get working on that soon. Thank you for watching. Goodbye.